welcome in. This evening we're talking about implicit differentiation. Now, first off, I need to separate this from what we've been doing in terms of derivatives previously. The first thing I need to point out to you is that everything we've done so far has been y equals some sort of function where this is only in terms of x or numbers and y is just some sort of y value or maybe an f of x. However, the relationships between these two variables are often expressed implicitly. And now that's a fancy way of saying that implicitly is I can't separate the x and the y. They have to be on the same side together. And they don't represent a single function since it's going to fail the vertical line test, i.e., here's the equation for a circle. Okay? And everybody knows this and hopefully is fairly comfortable with this. Now, if I'm going to try and take the derivative of this using the techniques that we've got right now, well, what I need to do is I need to separate this into, well, I'm going to have to say, well, I've got this over here, and I also have this over here, because when I subtract the x squared from both sides, then I have to take the square root of both sides, and when I take the square root of both sides, guess what? I'm going to be looking at two different equations. So when I take the derivative, I'm going to say, okay, that's to the 1/2, it's going to be to the negative 1/2, and I can cancel stuff. And I'm going to end up getting both this equation here and this equation here, which seems really kind of complicated. And my guess is at least a few of you are going, that's not something I would like to do. Is there a way to make this easier? And it is a bunch of unnecessary work. And let me show you how we can get around this using implicit differentiation. So what we're going to do is we're going to take that first example, and we're going to treat y as it being the inner function of some chain rule problem, and then we're going to take the derivative of each term. And I do that by saying, well, let's start off with, I take the derivative of each term here. And taking the derivative of this first term is pretty straightforward. It's just going to be 2x. Taking the derivative of this, you would think, oh, that's just going to be 2y. Except that the derivative of x, which I've got in here, and again, using chain rule, I would say that would be 2x times the derivative of x, and the derivative of x is just going to be 1. But I've got to take the derivative of y here, and that's where things go a little bit sideways. See, what I need to do there is I need to insert this dy term when I take the derivative of y. Now again, I have taken the derivative of x using the chain rule on this, it's just I've never discussed it. And then taking the derivative of any constant is just going to be 0. Okay, next up. I can then say, let's subtract 2x from both sides and then divide both sides by 2y. And I can say that the derivative of any point on the unit circle is just going to be negative x over y, as opposed to picking and choosing and saying, which equation am I supposed to be using? And that does come in handy and makes our life a little bit easier. We only have one equation that we really need to worry about. So it's a plus. When we can't isolate y, we can do implicit differentiation. The big thing I'm going to emphasize is, please, when you take the derivative of y and you write down that you're taking the derivative of y, use dy dx. Don't write y prime, because I will tell you from past experience, students just breeze right over that and they skip it and they just treat it as though it's a y, and then they can't find it. So let's take a look at an example. If I was asked to find the slope of these, well, all I need to do is just plug it into that one equation that I've done. So it's really not that hard. Now, let's take a look at this situation here and see what I can do about perhaps trying to come up with this using the techniques that I've got here. So once again, I can take the derivative of this, which is going to get me 2x. I'm going to use my product rule to get me that. I'm going to take the derivative of this, and when I take the derivative of that, I'm looking at 0. So let's see what I get there. Okay, no surprise, 2x. And then I'm going to take, I'm going to take the derivative of the first times my second, which is just the product rule, plus the first times the derivative of my second. I have to take the derivative of my y. Minus, okay, I'm going to use the chain rule. 3 comes down out front, decrease the power by 1. So I'm looking at 3y squared, but then I have to take the derivative of that inner function, which is dy dx. Okay, again, Notice I've written it as dy dx, so it's easy for me to identify stuff. Now, the goal anytime you're trying to find the derivative of one of these equations is just to isolate dy dx. So in this case, I'm just going to subtract these values over to the other side. No problem there. And now I'm going to take what's left and I'm going to pull out a dy dx. Not too bad either. And now just divide both sides through by that x minus 3y squared to isolate my variable. Okay, so now I've got an expression for any point on this line. And I'm told that I'm using this point here. So all I need to do is just substitute stuff in. And I suppose I could try and simplify a little bit, which is factoring out a negative from both of these. But I'm just going to substitute stuff in. By the way, I'm introducing this notation. When I write something like this, this means that with the bar and then this point written down here, that tells the person that's reading your test or your quiz or whatever work you're doing that, hey, I'm taking the value that I've had up here, and now I'm just substituting in what we've got here. And I'm indicating that I'm doing that substitution. Okay, next up. And so therefore, I'm just going to use the point slope form and the slope that I got here to say that that's going to be the equation of line tangent to the curve. Okay, next, give it a second, and you can pause if you need to. Okay, next up, take a look at this one, see what you can do, and I'd recommend pausing this for a second or two, see where you can get to. And I'm going to call time because, well, I'm not being paused by you. Now I'm going to take the derivative of this piece, derivative of this piece, and derivative of this piece. And so I end up with, well, the derivative of this is just going to be 2. But remember, I still have to take the derivative of y, so that's going to get me a dy dx. This is just going to be 2x. And here I've got another chain rule thing going on. So when I take the derivative of both sides, I'm going to have a dy dx on both sides of my equation here. Next, I want to collect all my dy dx terms together on one side. So I'm going to do that by subtracting cosine y dy dx. And now I'm going to put in parentheses what I've got there and factor out a GCF of dy dx. And now divide both sides through so I can isolate my dy dx. Ta-da! See, that's not so bad. Okay, once again, pause if you need to, copy stuff down, going once, going twice. All right, now this one's going to be a bit more of a challenge, and I'm going to warn you right now, don't get freaked on this one. It is more challenging. You just have to be, well, a little bit careful, and don't be in a rush when you're doing the implicit differentiation problems. Don't be thinking, oh, I've got 3 minutes. Let me see if I can knock one of these out. Take your time until you get comfortable with them. So what I've got here is another chain rule problem. I've got sine, and then there's my inner function, except that that's a product rule problem in there. Yeah. So that's going to take some time. So let's get to work on it. The derivative of sine gets me cosine xy, and then I'm going to use the product rule to get me y plus that derivative there, and boom, boom, boom. Okay. Now, once again, this is not fun because trying to get a hold of dy dx when I've got something that needs to be multiplied out, that's going to mean work. So I'm going to have to multiply cosine of xy times each term here. Now I can isolate things, and I can try and group my dy dx term here with my dy dx term here. And I'll do that by collecting them over on the left side, and I'm going to move this term over to the right side. Okay, and it doesn't look pretty, but once again, I can group this, treat my dy dx as my GCF, factor it out, and then divide by what I've got left, which gets me this. Now again, does it look pretty? Oh, heck no, but it's still a doable problem. Questions, comments, concerns? Okay. All right, then what I'm going to say at this point is I would recommend putting a pause on things. I'd recommend doing exit slip, and check your answers for day 1 before you proceed to part 2, day 2 on this, okay? So we've got that, and I'm going to say dig into that one. and then come back and mess with it in a second. Okay, and go.